Okay, now we're going to look at solving. So notice this isn't asking you to add together. It's saying if you added it together, you would get this expression. And notice there's a variable on each side, or even if there's not, the question is, what is the value of the variable that makes this expression true? So just a small reminder that when we had, in the past, fractions in equations, there was kind of this option of multiplying the entire equation by some value that was a good choice in order to cancel the denominators. And usually that value, the best choice, if you wanted to cancel all the denominators but not create a lot of extra factors, was to choose the least common denominator. And in this problem, there's a factor of 2, a factor of 5, and a factor of 3. So the least common denominator would be 30. And the reason we like that is when 30 multiplied the first fraction, 2 and 30, we just got 15. When 30 then multiplied the next fraction, x over 5 times 30, again, the denominator was canceled, and then we had 6x remaining. And when 30 multiplied the third fraction, 2/3 times 30, 3 and 30 had a common factor, and we got 20. And then we had an equation we could solve that didn't have any fractions in it anymore. So that's exceptionally helpful when we're looking at something like this, where we have variables in the denominator. So the first thing I'm going to do is I'm going to make sure that all the denominators are factored so that I can see what the greatest or the least common denominator would be. Okay, so what I would choose as my least common denominator. From the first factor, I have y plus 2. The next factor is 15. The next denominator has a factor of 3. That one factor of 3 is already captured in the number 15. And it has a factor of y plus 2, and that one factor of y plus 2 is already captured there. So I am going to use 15 times y plus 2 as my least common denominator, and I'm going to multiply this entire equation, both sides, by 15 times y plus 2. So notice in the first fraction, if I multiply it by 15 times y plus 2, the y plus 2's will cancel out, and I'll be left with 3 times 15, which is 45. In the second fraction, 7 over 15 is going to get multiplied by 15 and y plus 2. The 15's will cancel out, and I will be left with 7 times y plus 2. And on the other side of the equation, the right side where I have 23 over 3 times y plus 2, if I multiply that by 15 times y plus 2, the factors of y plus 2 cancel out, and the factor of 3 and the factor of 15 both have a factor of 3. And when reduced by that, we're left with a factor of 5. And 5 times 23 is 115. So I now have this equation that's simpler to solve. I'm going to distribute the 7. And so I have 7y plus 59 equals 115. So I'm going to have 7y equals 115 minus 59, which is 56. And then I'm going to get that y is equal to 8. Now, before I declare that this is my solution, I should check that it's true. And remember to check, we would take it and we would plug it into the equation everywhere there is a y and check that both sides are actually equal to each other. And so here I would have 3 over 10 plus 7 over 15. I would make a common denominator here. So I get 9 over 30 plus 14 over 30 equals 23 over 30. And on the right side, I get 23 over 30. So these are equal. So it does work. So I can go ahead and say that y equals 8 is my solution. Now, the main thing that would happen, I didn't do anything mathematically wrong, So the only reason that I would make a solution that would be called extraneous, which means I did everything mathematically right, but the solution's really kind of like an extra solution, it doesn't really work, is because the variable's in the denominator here, and there's certain things it can't be equal to. Look at our denominator. Basically, I'm really on the lookout here. Y cannot equal -2, because if that was the case, I would have denominators where there would be zeros, and those would be undefined, and I then cannot say that they're equal to certain values. So that's really what I'm looking for in this case. All right, so looking at the next problem, the denominators have been factored for us. So according to the first fraction, we need a factor of 3 and a factor of x minus 2. The next fraction has 6. Well, I have part of that with a factor of 3, but I'm missing the other factor of 2. And then the next fraction has x minus 2. I've completely captured that denominator here. So I need 6 times x minus 2 to be my least common denominator, and I'm going to multiply the entire problem by that. So in the first fraction, when it's multiplied by 6 times x minus 2, I have to cancel out the x minus 2's, and 3 and 6 have a factor of 3, leaving 2. So I have 2 times x plus 1 as my first term. On the other side of the equation, I have a 5x over 6 that I'm going to multiply by 6 times x minus 2. So the factors of 6 will cancel, and I'll be left with 5x times x minus 2. And then I have 1 over x minus 2, which I'm going to multiply by 6 times x minus 2. The x minus 2's will be canceled, and I'll left with 1 times 6, which is just 6. So I now have no fractions, and here is what my polynomial looks like when I multiply it out. Because it's a quadratic, I'm going to go ahead and bring all the terms to one side of the equation. So I'm going to have 5x squared minus 12x plus 4. And so then I'm looking to factor this. So again, either by guess and check, or the x in the box, or whatever factoring method it is that you choose to use, you should be able to factor this polynomial. And then we would set each of these factors equal to 0, and we would get solutions of 2/5 and 2. Now again, we can plug both of these back in and check, but I can see by looking at my original denominators what I was looking out for. Look back at the original problem, look at the factors in the denominator. 3 can't be equal to 0, and 6 can't be equal to 0. But if the denominator of x minus 2 is equal to 0, that's going to happen when x is equal to 2, which means that cannot be a solution. That's included in our solution set, so that one is extraneous, leaving only one solution, which is that x equals 2/5. Okay? So you can check and plug it all the way in, as you always can with solving any types of equations. But in this type, we can specifically look for those extraneous solutions by what would make the denominator equal to 0. Okay, so looking at the try this problem, let's go ahead and rewrite the problem with factored denominators. They all look good except for the last one's not factored. I can factor a 2 out of that, and it'll leave 2r plus 1. So for my LCD, from the first fraction, I need a factor of 2r plus 1. From the second one, I need a factor of 3. And then from the third fraction, I need 2r plus 1, which I already have, and a factor of 2. So my LCD is going to be 6 times 2r plus 1. So I'm going to multiply each term in this equation by 6 times 2r plus 1. So if I take my first term and multiply it by 6 times 2r plus 1, I'm going to cancel out the 2r plus 1, and I'm going to have 6 times r plus 2. Then I'm going to have r over 3, and I'm going to multiply that by 6 times 2r plus 1. And 3 and 6 have a common factor of 3, leaving 2. So I'm going to have 2 times r times 2r plus 1. And in the final term, 3 over 2 times 2r plus 1, when I multiply that by 6 times 2r plus 1. The 2r plus 1s will cancel out, and 2 and 6 have a common factor of 2, leaving 3. So that'll be 9. So now I have an equation again with no fractions, but I need to go ahead and go through and simplify this. And again, I have a quadratic, so I'm going to move all the terms to the same side of the equation to attempt to solve this. So I'm going to have 4r squared minus 4r minus 3. And so again, whatever method you choose to use for factoring is what you want to go ahead and do here. Okay. And then by setting each of those factors equal to 0, 2r minus 3 equals 0 will give us that r could equal 3 over 2. And 2r plus 1 equal to 0 will give us that r could equal negative 1/2. And so we now have these two solutions. And again, look at your denominators. Where would you create extraneous solutions? The only factor of the denominator in the original problem that could be set equal to 0 would be this one. When r is equal to negative 1/2, it will be 0, so r cannot equal negative 1/2. So that's gone, which means r must just equal 3 over 2.